Let's switch that over a little bit and add in a bridge or common pipe, primary, secondary, and the difference is there's a set of pumps for the bores and another set of pumps for the system. And that little green common pipe relieves it. So in this particular setup, we're using a dedicated pump per bore, and it's constant flow, and we've got distribution pumps that are variable flow. And we'll show a picture of that in just a second, a little more detail. But the message I want to get across to you real quick here, make sure you don't miss this. I now have a pump for each bore. If I cut that pump off, there's no flow through the bore. If I cut the pump off in primary, secondary, there's no flow through the bore. I just met ASHRAE 90.1 energy code without a two-way valve. I just made it a lot simpler. Now my pump and my bore are tied together. They cut on and off together. You got a bit of delay in running to get the residual heat out of it from the bore, but the message is I've just cleaned my controls up a lot more simple. Let's take a little bit further look at this picture. Now here's the whole system again. Primary, secondary, I've got constant flow through the bores. I got a dedicated pump per bore. I've got a little green common pipe. So that bore pump just goes round and around and around in an equipment room. Then I have my roll air troll. I got a couple of distribution pumps that are variable speed. And you see I'm sensing the critical zone with a variable speed, varying the speed of my pumps back and forth. And you will also note there's a three-way valve out of the end for that minimum flow rate of my pumps. That minimum flow rate of my pumps. So let's back into this. What have I done? I now can set my bores up constant flow, and I don't need a flow limiter, and I don't need a two-way isolation valve for my bores. And I got constant flow because of that common pipe. I'm not worried about min and max flow of my bores. Once I set them up and do a manual balance to begin with, I'm home free. Let's go beyond the common pipe on the distribution side. Now I've got variable flow, and I have my three-way valves way out at the end to make sure I have the minimum flow rate for my system. The beauty of that is to enable this system, you turn on the distribution pumps, the variable speed pumps, and they flow through the heating coils if they're open and through three-way valves around and around and around. So you've got your enabled on. You're not necessarily flowing through the bores yet. All those pumps can be off, and you're saving that energy because they're not even running right now, and you're not putting pressure flow through the bores. You're not wasting that energy. And they will only come on when you get a call for heat. So now you've isolated it, made it a lot simpler, and I think this makes a lot of sense. Now, if you start looking at it a little bit further, and you start looking at details of this, what do you see happening here? What you see in a primary secondary system is that the supply water temperature is not quite as critical as in a chill water system. In other words, you can let it mix a little bit. Chill water, you don't want mixing too much, but you know, hot water heating system, the little mix is not going to hurt you. In other words, it would be okay for your system flow rate to be greater than the flow rate through the bores. Your supply temperature would be mixed, come down a little bit, but it's not that critical. You can eliminate the need for the two-way bore isolation valves. That's huge. Those things can be tricky to set up, they're expensive. You can eliminate the need for the flow limiters. You get rid of those. Your controls are more simple and easy to operate. Boiler pumps will be staged on and off with a call for heating, and you save pump energy at night. They are constant flow, so therefore you're wasting some energy if you're fully flowing through the bores when you don't have full fire. That would be the thing that we need to take a look at. And guess what? We got an answer for that. The answer for that is, and I think the very future of condensing boilers is going to be variable speed primary, variable speed secondary. Can save you a lot of pumping energy. And to make sure you don't misunderstand that concept, let's look at it real quick. Now, we're back to primary secondary, but we made a major change here. Each boiler has a pump on it just like before, but instead of those boiler pumps being constant speed, they're now variable speed. Yes, we're going to vary the flow in a primary secondary system on both sides. We're going to vary the flow on the primary side of the water going through the bores, and we're going to vary the flow on the secondary side of the water going through the system with the two-way valves. Wow, that's a major change, but we still eliminated two-way valves. We still eliminated the flow limiters. We got the controls a lot simpler. And energy-wise, pumping energy, we're going to save more energy this way than variable primary pumped. Why? Because when those boilers are not being fired, there's no flow to cut the pump off. And if you're in variable primary pump, you still have flow through the boilers because there's no other way to make it work. This is the way of the future. This is the way it's going to be. Pretty neat idea here. What these variable speed drives are doing on those boilers is they're going to match the flow through the boiler down to the minimum flow in each boiler to the load. In other words, if your load is 50%, you're going to cut your flow rate in half. In essence, what they're doing on the primary variable flow side, the primary secondary, is they're trying to hold a constant delta T across those boilers. And if you go to a fire tube boiler versus a water tube boiler, the pressure drop through those boilers are 2-3 feet, extremely low. So now we take in the energy pump-wise going through the boilers and just reduced it down dramatically to a low number. In other words, efficiency-wise, we're there. There's not much more you can do now because we're varying the flow through the boilers and we're varying the flows through the systems, and we're trying to make sure we keep the pump energy to a minimum. And we're using condensing boilers at 97, 98% efficiency. You are really humming in on it now.